Okay, Assalamualaikum to Zulfairul. In this video, me, Husna Shuhana, and my partner, Muhammad Ashraf Daniel, going to share the chapter in week 12, which is filing and bricklaying work. So, the content in this video is filing, bricklaying, design and selection of the permanent works, case study for book works, and conclusion. So let's get started with piling works. What is piling works? Piling is the process of driving or boring pile foundation into the ground beneath a building that is under construction. The main component of the foundation are the pile caps and the piles. Piles are long and slender member which transfer the load to a deeper capacity. The main material used for the piles are wood, steel, and concrete. Piles are made from this material are driven, drilled or jacked into the ground and connected to the pile caps. Depending on the type of soil, pile material and load transferring are classified accordingly. Next, we move to the purpose of the piling. The purpose of the piling is to transmit a foundation load to the solid ground and to resist the vertical, lateral, and uplift loads. A structure can be found on the piles if the soil immediately beneath and its base does not have adequate bearing capacity. If the result of the site investigation show that the shallow soil is unstable or weak, or if the magnitude of the estimated settlement is not acceptable, a pile foundation may be considered. Next, the characteristic of the pile foundation. These are the following diagram represent the different types of the piles in the construction. So basically, pile foundation can be divided by two, which is based on the function or use and based on the material and construction method. First, we look to based on the function or use. There we have 5 types of piles, which is sheet piles, load-bearing piles, end-bearing piles, friction piles, and soil compactor piles. Meanwhile, for the pile foundation under based on material and construction method, we have 4 types, which is timber piles, concrete piles, steel piles, and composite piles. Okay, next we move to the next slide, which is type of piles. So basically, when determining the best piling type for the project, building engineer need to examine the range of factors, including the depth of the excavation, the angle at which the piles need to be installed, and the environmental issue that impacted by a resident. So here are the 5 main piling types of the construction that workers can consider, which is end-bearing piles, friction piles, board piles, driven piles, and screw piles. First, let's go to the end-bearing piles. The bottom of the end-bearing piles rests on the layer of the strong soil or rock. Engineers design this type of piles to transfer the heavy load of the building through the piles onto the strong layer. Its essential is a column that cuts through a weak layer of the ground so that the structure can remain upright with the support of the stronger layer underneath. Okay, for the second piles is friction piles. Friction piles are basically cylindrical. They use their full height to transfer the forces a building generates into the soil. In the friction piles, the amount of the load a pile can support is directly proportionally to its length. This also means that a greater depth, the pile can hold more weight. The third piles is board piles. Board piles need to auger into the ground to form a hole that worker can later fill with poured concrete. The benefit of this type of pile is that it's cast into position, meaning that board piles are extremely secure. Construction projects in cities use board pile because the installation process results in less vibration when compared to other methods. Okay, the next slide shows us the driven piles. Okay, the driven piles needs a lot of force to hammer into the ground. This type of pile is common for foundation that have no cohesive soil or soil that contain many contaminants. So the last one is screw piles. Screw piles look like large steel screw that need to be fastened into the ground using a similar circular motion, regular screw to attach to the other surface such as wood. Okay, we're moving to the next slide, which is piling material selection and their specification. So basically, there's three types of material that currently used in construction of piling, which is timber, concrete, and steel. Okay, first one, let's look up at the timber. Timber piles are the types of the pile foundation that are placed under the water level. They last for approximately about 30 years. They can be rectangular or singular, and diameter or size can vary from 12 to 16 inches. The length of the pile is usually 20 times the top and width. Additional strength can be obtained by bolting fish plate to the side of the plate. So there is advantage and disadvantage of the timber piles, which is for advantage we have timber piles are regular size. In every regular size are available, economical, easy to install, low possibility of damage. Timber piles footing can be cut off at any desired length after they are installed, and then if necessary, timber piles can be easily pulled out. Meanwhile, for the disadvantage for the timber piles is the piles are longer length are not always available. It is difficult to obtain straight piles if the length is short. It is difficult to drive the piles into the soil strata, and it's very hard. Splicing the timber piles is difficult, and the last one is timber or wooden piles are not suitable to be used as end-bearing piles. Okay, we move to the next material, which is concrete piles. So basically, there's two for concrete piles, which is precast concrete piles and cast-in-place concrete piles. I will tell first about the precast concrete piles. The precast concrete pile foundation is cast in the pile bed in horizontal form if they are rectangular. Usually, circular piles are cast in a vertical form. Precast piles are usually reinforced with steel to prevent breakage during their mobilization from the casing bed to the location of the foundation. After the piles are cast, curing has been performed as per specification. Generally, curing period for precast pile is 21 to 28 days. So same goes to the timber piles. The advantage they are for precast piles. The advantages and disadvantages has been stated in the slide. We move to the next, which is cast-in-place concrete piles. This type of pile footing is constructed by boring soil up to the desired depth and then depositing freshly mixed concrete in that place and letting it cure there. Cast in situ concrete pile foundation is constructed either by the driving a material metallic shell to the ground and fill it by concrete and leave it shell with the concrete, or the shell is pulled out while the concrete is poured. Usually, round piles are used in the cast in situ piling. Okay, these are the advantages and the disadvantages of the cast in situ concrete piles, which is, for advantages, we have the shell are lightweight, so they can easily to handle. And second one, the length of the piles can be very easily. The shell may be assembled at site, and then no access enforcement is required only to prevent damage from the being handled. No possibility of breaking during installation. And the last one is, additionally, piles can be provided easily if required. Meanwhile, for the disadvantage for the cast in situ concrete piles is, firstly, is installation requires careful supervision and quality control. Need sufficient space on site for storage for the material used for construction. It is difficult to construct cast in situ piles where underground water flow is heavy. And then the bottom of the pile may not be symmetrical. And the last one, if the pile is unreinforced and uncased, the pile can be fail in tension if it acts like an uplifting force. Okay, the last one is steel piles. Steel piles may be L version or hollow pipes. They are fit with concrete, and the size may vary from the 8 I'm mistaken 10 inches to 24 inches in diameter, and the thickness is usually 3 per 4 inches. Because of the small sectional area, the piles are easily to drive, and they are mostly used as the end-bearing piles. So basically, the advantages and disadvantages of the steel pile is, the advantage of the steel piles, firstly, is they are easy to install. And the second one is, they can reach the greater depth compared to any type of pile foundation, can penetrate through the hard layer of the soil due to less cross-sectional area, easy to splice steel piles, and can carry heavy loads. Meanwhile, for the disadvantage of the steel pile is, this piling is prone to corrosion, has a possibility of deviating while driving, and comparatively is expensive. Okay, next we move to the case study. Polytechnic Kota Kinabalu is located at Kota Kinabalu Industrial Park, KKIP, Jalan Polytechnic, Kota Kinabalu, Sabah. The construction of this project commenced in 1999 and was finally complete in 2003. Structural cracks were later detected at one of the main buildings on the campus, which is Core Facilities Building and the Teaching Restaurant. At the point of the investigation, the drainage system, such as perimeter drains, had also experienced serious settlement. Okay, in November 2004, Kumpulan Ikram Sabah Sdn Bhd was appointed to conduct a structural assessment and geotechnical audit on the problematic building. So basically, these are the purpose of and scope of work that has been done. The scope of work that has been done is physically investigation works, including visit, visual inspection, and necessary material and structural testing. They also had monitoring work, including defect and crack mapping, monitoring of settlement and movement of the teaching restaurant. They also proof checking of the structure of the building and carry out the soil investigation works. They also carry out geotechnical analysis and ascertain the integrity of the pile foundation. They also recommend for remedial works. Next slide is, so basically these are the proper solutions that has been done to overcome the problem of the building. First one is settlement analysis and monitoring. They have three solutions, which is settlement analysis and monitoring, piling records, and pile task load. So firstly, for the settlement analysis and monitoring, back analysis was carried out by the investigation team to predict the magnitude and rate of the consolidation process at the site. Compressibility parameter obtained from the soil investigation work that have been in analysis with the assumption that 7.2 meter of the field act as a surcharge load on 10.6 meter and 11.6 meter of the soil compressively layer respectively. So in table 2, these are the result of the magnitude and rate of anticipated settlement due to the 7.2 meter thick of the fill material. Next we move to the second solution, which is piling record. The further inspection of the piling record has been conducted by the investigation team to ascertain the actual cause of failure. From the summary of the provided piling records, 250 mm times with 250 mm reinforcement concrete square piles have been used as a foundation for the building. Installation of the piles was carried out by using a hydraulic hammer with a final set seritation with based on the blow count for the last 300 mm of the penetration. A simple calculation by dividing the penetration of 300 mm with the recorded total last blow counts indicated that the piles may not be properly set during the installation. Some piles were proven to be settled through the settlement monitoring on the column, even though the piles driving record revealed that the piles had achieved a set of 12 meter per 10 blows. Okay, next we move to the third solution and the last one, which is pile test load. So basically, for the table 3 shows us that the pile allowable bearing capacity. The static load was conducted on the longest piles with a penetration depth about 27 meter to verify the design. However, no load test has been conducted on the shorter piles with an average penetration depth about 24 meter, which is mostly found at the block B of that building. Therefore, the main cause of the problem is possibly due to the overloaded piles when subjected to the negative skin friction that develop over time because of the settling ground. This phenomena has led to the occurrence of differential settlement of the pile foundation that cause crack in the building. Next, the last one from me in the conclusion. The observation shows that the pile foundation is used where the soil stability is less, So the pile foundation is mandatory in such a place where the soil is less stable for heavy construction such as bridge, flyover, and etc. Low bearing capacity soil have physiomechanical properties recurring through the investigation, especially when the pile foundation are to be constructed. Depending on the type of structure, soil condition, expertise, and finance, drive piles, or we know as displacement piles foundation installation technique most used include dropping weight, hammer, explosion, vibration, jacking, screw, jetting, or a combination of any these. So that's all from me. I would like to pass the presentation video to my partner, Ashraf. Thank you.
So, Assalamualaikum warahmatullahi wabarakatuh. So, I want to explain further about one of the permanent work in construction, which is bricklaying. So, let's move to the definition of bricklaying. Bricklaying is a construction skill or trade that involves the arrangement and placement of brick or other masonry unit to create structures such as wall, partition, and also other brick build features. Bricklayer, also known as mason, use mortar, a mixture of cement, sand, and water, to bond the brick together, forming a sturdy and durable structure. The process requires precision and skill to ensure that the bricks are laid evenly, aligned properly, and adhere securely to the mortar. Bricklaying is a fundamental aspect of masonry construction and is utilized in various types of building projects, including residential, commercial, and also industrial structure. So next, we will take a look on the importance of bricklaying works. There are several, which is structural integrity, versatility and also aesthetic, durability and longevity, sound insulation, fire resistance, environmental sustainability, and also cultural and historical significance. Okay, so the first important is structural integrity. Load bearing support. Bricklaying is often employed to create load-bearing walls that provide structural support to building. The interlocking arrangement of brick along with the mortar creates a solid and stable framework for the structure. Okay, so the second importance is versatility and also aesthetic. It's more on architectural design. The versatility of bricklaying allows for diverse architectural design, various pattern, texture, color of the brick that can be used to achieve the aesthetic goals, enhance the visual appeal of a structure itself. The third one is durability and longevity. It's more on weather. So we can see that weather resistant. Okay, brick are known for their durability and resistant to weather element. Bricklaying contributes to the creation of resilient structure that can withstand harsh environmental conditions that ensuring longevity. The fourth one is sound insulation. More on insulation properties, that brick can possess natural insulation properties, helping to regulate indoor temperatures. Brick walls can contribute the energy efficiency by reducing the need for excessive heating or cooling. Then also the importance is fire resistant. Okay, fire safety. Brick are inherently fire resistant that can provide an added layer of safety to certain building. Okay, bricklaying in critical areas such as firewall. Okay, it can help to contain and prevent the spread of fire when anything happen. Uh, Next, also we have environmental sustainability. Okay, recycle and sustainable. We can see that we are often made from natural material. You can see like clay, shale. Okay, that it will make them recyclable and also environmental friendly. Their durability also contributes to sustainable construction practice. And also the last one, important is for cultural and historical significance, tradition and heritage. Okay, bricklaying technique have been used for centuries, contribute to the cultural and historical significance of many structures. Okay, the craftsmanship involved in bricklaying is often seen as an art. Okay, so in summary, we can say that bricklaying is integral to construct work due to its contribution to structural stability, aesthetic appeal, and also durability. Okay, so next we will move to the process of making brick. Okay, starting from the selection of raw materials, uh, preparation of clay, forming the brick, drying, firing, also sorting and packaging. Okay, so the first one is selection of raw material. Okay, starting from the clay extraction, uh, primary raw material from brick is clay. Okay, we can see it is usually obtained from natural deposit or mines. The quality of the clay is crucial, okay, as it was determine the characteristic of the final brick. The next is the preparation of the clay itself. By using weathering technique, okay, the extract clay is often left exposed to the natural element for a certain period, okay, usually for a long time. This process known as weathering to help break down large clump and also improve the plasticity of the clay. Then also have the blending process to differentiate type of clay to achieve the desired properties. Then the next process, the third process is forming the brick. Okay, forming the brick. Hmm, I actually have two methods. This is molding and also extrusion. Molding, they prepare the clay, then molded it into the desired shape lah. Okay, this can be done using various methods such as hand molding and also using machine. Then also we have extrusion. Okay, nowadays in modern brick manufacturing, some process use extra dust to form a continuous column of clay, uh, which is then can cut into individual brick. Okay, so the next process is drying. Okay, two types: air drying and also mechanical drying. Okay, air drying, the fresh molded brick are left in the open air to dry naturally. Okay, it takes several days and it's crucial to remove excess moisture from the brick before firing. And also have mechanical drying. Okay, in some cases, mechanical dryers or drying chambers are used to speed up the drying process. Okay, then have firing. Okay, firing, which means to burn the brick. Okay, firing process involves subjecting the brick to high temperature, so typically between 800 to 1200 degrees Celsius. Okay, so this process is to making the brick hard and also durable. Okay, and then after firing, they have cooling. So cooling is to allow the brick to cool slowly. Okay, because we want to prevent it from cracking and warping. Okay, and the last process is sorting and packaging. Okay, this is important for the quality control. Okay, the fire brick expected. Okay, for quality. Okay, including the dimension, the color, the structural integrity. Okay, because if there happen any defect, okay, the brick may be discarded. And also the final step is packaging. Okay, for distribution and sale. Okay, basically, typically they are stacked on a pallet and wrapped to protect during transportation. Okay, so next is type of brick. There are several type of brick. Mm, okay, type of brick. We have clay brick, sand cement brick, concrete brick, calcium silicate brick, and fly ash brick. So firstly is clay brick. Okay, clay brick, most basic and traditional type of brick. So basically made by molding clay and firing it in the clay. Then we have sand cement brick. So this type of brick are manufactured at higher temperature that will resulting in a dense and strong product. We also have concrete brick, okay, made from a mixture of cement, sand, aggregate, and cured by steam or water. Then we have calcium silicate brick. Okay, Basically, they are made by mixing sand, fly ash, lime, followed by a chemical process of hydration. And also the last one, we have fly ash brick. Basically made from fly ash, a byproduct of coal combustions combined with cement, sand, and water. Okay, then we have let's move to the type of mortar. Basically, we have four: cement mortar, lime mortar, gauge mortar, and also mud mortar. The first one is cement mortar. Okay, cement mortar is a mixture of cement, sand, and water that used in construction to bond necessary unit and provide strength, durability to the structure. It is a fundamental component in bricklaying, block work, and also other forms of masonry construction. The proportion of cement, sand, and water can be adjusted based on specific requirements of the construction project. The next one is lime mortar. Mm, Lime mortar is a type of mortar composed of lime, sand, and water. It is a traditional building material that has been used for centuries in construction. Lime mortar has distinct properties that make it suitable for certain applications, particularly in historic preservation, restoration work, and also for specified type of masonry construction. There are different types of lime mortar. Primarily can categorize as hydraulic lime mortar and also non-hydraulic lime mortar. Okay, the next one is Scotch mortar. Gauge mortar is a type of mortar that involves the precise proportioning of gauging of its constituents to achieve uh, specific performance characteristic for the mortar itself. Unlike traditional mortar mixes where the proportions are not precisely measured, gauge mortar involves careful control of the mix to achieve the desired qualities such as the strength, uh, the color, and also the structure itself. This type of mortar is often used in decorative masonry, plastering, and other specialized applications. And the last one is mud mortar, also known as earthen mortar or adobe mortar. It's a traditional building material made from natural. So basically, locally there are source materials such as clay, red soil, sand, straw, and sometimes other organic material. It has been used for centuries in the construction for earthen structure, including adobe houses and other type of mud brick building. Mud mortar is a simple, is a cost-effective, and also very environmental friendly material that often choose for its availability and sustainability. Okay, so the next one we will discuss about the brick bonding method. So basically we have five method: header bond, stretcher bond, English bond, and Flemish bond, and also Dutch bond. So we can see the first one is header bond. Okay, header bond. It has only header in each course of wall, and normally used in the construction of footing and walls with sharply curved. Okay. Next we have stretcher bond. It has only stretches in each course of the wall, except at top end of wall at each alternate course. A half bed brick is placed. Then we have English bond. This one it has course of headers alternate with courses of stretches. In this bonding, every alternate header in the course sits centrally over the joint between two stretches in the joint, except at certain stop end. In each heading course, a queen closer is placed next to the queen header, and the rest will be header. Okay, as shown in the figure. Comparatively, lack of straight join therefore give this bond as the strongest if you compare to all the bond method. Okay, then we have Flemish bond. Uh, Flemish bond comprises of alternate headers and stretches in each course. And the last one is Dutch bond. Dutch bond consists of alternate course of header and stretches. but each stretching course begin at the coin with a 3/4 bat, and every alternate stretching course has a header placed next to the coin 3/4 bat. Okay, so if you guys can see in the figure, okay, how Dutch point. Okay, next the quality control. Quality control. Quality control. We have four: material quality control, workmanship standard, inspection during construction, and also the weather condition. Okay, so let's take a look on material quality control. We have two elements: brick inspection and also mortar quality. Okay, so for brick inspection, we must verify that the brick, okay, meet quality standard in terms of size, shape, color, and absence of defect. Okay, these include checking for crack, chips, or other imperfection. Okay, the next element is mortar quality. Conduct inspection of the mortar mix, ensuring it meets all the specification in terms of proportion, consistency, and absence of contaminants. Okay, the next one is workmanship standard. Okay, we have four elements here. Okay, which is alignment and leveling, joint thickness, tooling of joint, bonding. Okay, alignment and leveling regularly check the alignment and leveling of the brick during the construction to ensure that walls are plumb and level. Joint thickness, verify the consistency of joint thickness throughout the construction. Tooling of joint, okay, we must inspect the tooling of mortar joint for uniformity and cleanliness. Last one is bonding. Okay, confirm proper bonding between the brick. Okay, with full mortar coverage to ensure structural integrity. Alright, so the next one is inspection during construction. We have two elements: regular check and also detailed record. So what is regular check? Regular check, conduct frequent inspection during the construction so that we can identify and rectify issue that happen in that time. Okay, this involves spot check on workmanship, uh, on the material quality, okay, and adherence to construct method. And also need to have a detailed record. Okay, detailed record, maintain a comprehensive record of material specification, mixing proportion, construction method, and any charge made during construction, and the inspection result. And the last one is weather condition. Okay, we need to make a monitoring and adjustment. Okay, monitor the weather condition and adjust construction practice accordingly, especially in situation where adverse condition could impact the quality of bricklaying work. Alright, so let's move to the next one. Uh, Structural design consideration. Okay, we have four: load bearing capacity, dead load and live load, foundation design, and also quality control during construction. So for load bearing capacity, we can see we have two elements there: material property. Okay, material property, we need to understand the property of brick and mortar. Okay, including compressive strength, elasticity, and durability. Okay, because different type of brick have distinct load bearing capacity. Okay, then next element is structural grading. We must consider the grading and quality of the brick to determine their load carrying capability. Okay, second element there is dead load and live load. Okay, we must consider the material weight, okay, and uniform and concentrated load. Okay, for material weight, we must account for the dead load for the structural component, including the weight of the brick, mortar, and any additional material. Okay, we can consider live load such as regularly we have furniture and so on. Second element is uniform and concentrated load. We must analyze both uniform and concentrated load to determine their impact on different sections of the brick masonry. Then the third element is foundation design. Yeah, we must take a look on the soil analysis type of foundation. So for soil analysis, Must conduct a thorough analysis of the soil condition to design appropriate foundation. Okay, different soil, we know that different soil have different varying capacities and settlement characteristics. Also type of foundation. Must choose the most suitable foundation type, such as footing or deep foundation based on the soil condition and structural requirement. Okay, and the last element is quality control during construction, inspection and testing. Okay, we must implement quality control measures during construction, including inspection and material testing, to verify that the constructed brick masonry meets design specification. Okay, so for material selection and specification, we have three here. So brick selection, mix proportion, also the enforcement. Okay, so for brick selection, must consider the type of brick, the compressive strength, the color and texture. So for the type of brick, choose brick based on the specified requirement for the project. Common types include clay brick, concrete brick, okay, and so on. Compressive strength. Consider the compressive strength of brick, especially in load-bearing application, because different type of brick having a different strength. And then color and texture. Select brick that meet aesthetic requirement considering the colors, texture, and surface finish. This is particularly important in architectural project. So for mixed proportioning, specify the proportion of cement, lime, and sand in the mortar. And also consistency. Define the desired consistency of the mortar, ranging from the stiff to plastic, based on the specified needs of the project. And last one is enforcement. Use of reinforcement. Determine whether additional reinforcement such as vertical and horizontal steel bar for a mesh is required to enhance the tensile strength and ductility of the brick masonry. And also enforcement specification. Provide specification for the type, size, and placement of reinforcement, ensuring compliance with design requirements. Okay, quality control and standard compliance. So building codes and standard, material standard, construction document, and also the workmanship standard. So for building code standard, we have adherence to codes. We must ensure that all bricklaying work complies with the local, national, and international building codes and standard. We must update and make a revision. We must stay informed about any update or revision to building codes and standards to ensure ongoing compliance. So for the material standard, okay, we must follow the specification adherence. We must ensure that all materials used in bricklaying, including the brick, the mortar, the reinforcement, and other components, meet the specified standard and specification, and must have certification. We must verify that material come with the appropriate certification, indicating compliance with industry standard. So the next one is construction document. Review and make an approval. Ensure that construction document, including the drawing, specification, are thoroughly reviewed. Must make a review and approved by relevant authority before commencing bricklaying work. And also the as-built documentation. Uh, must keep accurate as-built documentation to record any change made during construction while maintaining the compliance. And last one is the workmanship standard, training and skill level, alignment and leveling. Mm, Training and skill level, I can say that must ensure that the bricklayer possesses the necessary training and skill to meet the workmanship standard, and also for alignment and leveling. Regularly check the alignment and leveling of brick to ensure the structural integrity and aesthetic of the finished work. Okay, so for my case study, uh, I choose Sagrada Familia Basilica located in Barcelona, Spain. So the Sagrada Familia Basilica is designed by renowned architect Antoni Gaudi, the iconic landmark in Barcelona, Spain. The ongoing construction and restoration of this masterpiece involve intricate bricklaying work, combining artistic vision with structural complexity. Okay, so let's take a look. What's the impact of the building, the construction. So here we have three: architecture influence, tourism impact, and also the global impact. Okay, so let's see the architectural influence from the two perspectives: innovative design and also architectural legacy. Okay, so Anthony Gaudi's design for the Skoda Familia is considered groundbreaking and innovative. It's a very unique blend of Gothic and art style, coupled with intricate details and symbolism as influenced architect worldwide. And also for the second perspective, you can see from architectural legacy, the ongoing construction has contributed to the Basilica's status as an iconic symbol of Barcelona and a UNESCO World Heritage Site. It served as a source of inspiration for architects and artists, showcasing the possibility of combining tradition and modern architectural elements. So the second one is tourism impact. Okay, it became the tourist attraction. Okay, so basically the construction site has become a major tourist attraction, drawing millions of visitors each year. Tourists are fascinated by the ongoing construction, the architectural marvel, and also the unique opportunity to witness the evolution of a historic structure. And it also leads to the economic boost because the tourism generated by the Sagrada Familia provide a significant economic boost to the local economy. It support job in hospitality, transportation, local business, contribute to Botswana overall economic vitality. And also the third one is global collaboration. We see in the perspective of international collaboration. The construction and restoration uh, efforts involve collaboration with experts and professionals from various countries. This global collaboration enrich the project with diverse perspectives, skills, and cultural influence. Okay, so for the challenge, I might share two challenge while doing this building, which is the long construction timeline, also the weather condition. Okay, for um, okay, so let's see the public location. All right, so let's see the first challenge, which is the long construction timeline. Okay, complex design. The intricate and unique design envisioned by Anthony Gaudi presented challenge in terms of engineering, construction method, and also coordination, leading to a significantly extended construction timeline. So the other challenge is weather condition. Okay, uh, exposure to element the construction site, exposed to the element during much of the construction process, face challenge related to weathering, affecting the preservation of material and construction schedule. Okay, so it's a lesson that we have learned. We have two lessons learned: balancing the tradition and innovation. So this is lesson learned from the case study. And then funding challenge, impact, construction. So let's take a look on balancing tradition and innovation. Integrating modern construction technique and material with traditional craftsmanship is a delicate balance. The Sagrada Familia highlight the importance how to adapt to technology advancement while preserving the authenticity of historical design. And also, the second lesson that we can learn from this case study is funding challenge impact the construction. Okay, relying on donation and visitor fund can lead to financial challenge and fluctuation in the construction timeline. Sustainable and secure funding mechanisms are crucial for the success of long-term project. Okay, and then the last one, the conclusion. Assessing suitable construction method for both permanent and temporary work is crucial for ensuring the overall success, safety, and efficiency of construction project. In permanent work, the choice of construction method directly impacts the structural integrity, durability, and also aesthetic coherence of the building, influencing its long-term performance. Compliance with building codes, cost consideration, and also environmental sustainability are key factors that require careful uh, assessment. For temporary work such as scaffolding and formwork, Suitable construction methods are essential for ensuring the safety of construction workers, optimizing efficiency, facilitating flexibility in response to evolving project needs. Both permanent and temporary works uh, or permanent and temporary construction method can contribute to risk management, project efficiency, quality assurance, and client certification, underscoring the holistic importance of strategic and informed decision making in the construction industry. So I think that's all for me. Thank you and Assalamualaikum.